Good morning, and let me thank you for your perseverance. It's inspiring. I'd like to start out by pointing out that in this week's New Yorker, there's a marvelous article about NVIDIA, the chip producing company that really has enabled much of artificial intelligence to move ahead. And in fact, it's served NVIDIA so well that it has just recently become one of the $5 trillion firms in the United States. So I guess we'll begin. I want you to just start thinking about the following. About how do you think and respond. For example, I ask you, what state were you born in? And you immediately don't think naked. You think of the actual state in the Union that you were born in. And so you understand my question and respond with your answer. But you're totally unaware of how you managed to do that. You understood the question, came up with the answer, and it was all the result of some very complex stuff going on in a biological neural network that we have inherited by virtue of evolution. So it should not be surprising, though it was to me, that the recent progress in AI responding in a human-like manner was accomplished by employing supercomputers of sufficient power that they can process spoken words in models of complex neural networks. Neural networks were first proposed way back in 1944 by Warren McCullough and Walter Pitts, two University of Chicago researchers who moved to MIT and in 1952 were founding members of what is sometimes called the first cognitive science department. But it took 70 years to produce computers that are up to the task of supporting something like chatGPT 4. But over the past few years, that threshold has been passed, and the progress has been remarkable, as we saw last week. So today I'm going to take on the rather difficult task of trying to tell you about how GPT works, ChatGPT works. And I'm sure it's going to be frustrating for some of you, but I won't feel that I've done right by you without trying to provide a sense of how it works. And one reason I'm doing that is I had absolutely no idea myself about how that damn thing could work. And so it was a kind of a learning experience, and of course I don't understand it at the deepest level, but I do have a sense of how you would go about this, even though I am surprised at why they do this with such enthusiasm and effort. Now, it's believed that your brain is a form of complex neural network whose workings are still somewhat obscure. In a human brain, there are 84 billion neurons and an equal number of supporting neurons in your brain with a supporting glial cells. That's kind of what it looks like. The colors, of course, are the work of an artist. Now, computers, so now we're going to try to deal with this thing called artificial intelligence. Computers only work with numbers, and in fact, a computer only works with two numbers, 0 and 1. It's a binary system, and so there has to be some way to get a computer to deal with letters and words? Well, of course, the first thing you notice yourself is, if you have a computer, is that the keyboard has letters in it, and you hit the A, and an A appears on the screen, even though A certainly isn't a letter. And of course, what's happened is everything that's on your keyboard has been understood by a series of binary numbers called an ASCII code that translates all your keyboard strokes into a binary code that the computer can actually execute. So when programmers go about establishing an AI chat that can both understand us and respond, to my mind, they were just facing a very difficult, and I thought, what a strange way to go about it. But at any rate, so you would think, okay, let me start with a vocabulary of, let's say, 50,000 words. Well, the dumbest thing I could have is a string now of binary representations of the numbers of 1 to 50,000 and identify a word with each one of them. But what would that have to do with the content and the meaning of each word? So when developing the capability of a program like ChatGPT, it has to have an extensive vocabulary that's been rendered useful for the computer to be able to deal with it. And there are three basic steps involved in accomplishing that. I call them here generating tokens. The words, of course, don't are just made up. They are used commonly in the AI world. Tokens, and a token is then translated into a word vector, and you then embed the word vector as a series of numbers. So tokenization is just a process of cutting up the original text, that is the original language, individual pieces that you call tokens. Each token is assigned a unique identification number that represents it. Then those unique ideas are then assigned to a randomly initialized n-dimensional vector. So a word is no longer now just a single thing, because if it just stood as a single thing, it wouldn't be very useful. So you are able to associate with each word a whole string of meanings. That's why you call the thing you've made a vector. So there are many components to that word, and as you'll see, I'll show you what they look like. And then you embed that vector as a series of numbers into the computer, and it's that the computer and the model is able to work with. As a result of this very extensive training, Chat has tokenized a vocabulary of about 50,000 words. So the words in your query, so you ask it to do something for you, are then converted into tokens. Then the tokens are vectorized and embedded into ChatGPT, and that's the model that ends up formulating a response. So here I've just taken and gone into a extreme two-dimensional projection of a set of words that I put in a two-dimensional space, but you should understand that the colors mean they're pointing off in different directions. So each one of those things is in a different space. And if you're smart enough to arrange things in that multi-dimensional space, you could end up doing a very clever thing like I've shown here. Make a little equation in which king minus man plus woman equals queen. You start to see, oh, maybe I could get to work on this and do something about it. Well, they've been working on that in a sense now for about, I guess this showed up around 2015, this thing. So GPT-3 has a vocabulary of 50,000 and those 257 ASCII tokens. And each token is represented by a vector. And a vector can be as long as 12,888 elements in it. This vector representation is called an embedding, and an important concept that helps to capture the semantic meanings of the tokens. Distance and cosine, directionality, similar, are used to identify words. So this thing that I've shown you off here, this thing is the components of the vector. So here we have a list of tokens: king, queen, woman, man, princess, and other royalty, masculinity, femininity. And you can see that what you have are entries of the likelihood of each one of those words being associated with the particular token. So a queen is certainly high probability of royalty, low probability of masculinity, high probability of femininity, and well, often of rather median age, and so on. So you could see how you make this very elaborate system where words are taken, converted into vectors, and embedded in the computer. And you can see you are giving the computer a really big thing to swallow, to digest all those 50,000 words, and each word being represented by as many as 12,000 elements. So you need large and powerful computers to deal with that. So, so how does ChatGPT end up going to work? Well, it has 175 billion parameters in it. This is, for the most part, I'm talking about ChatGPT 3 and ChatGPT 3.5. This one is 3.5. Vocabulary size is 50,000 words. At the very beginning, you have to give the computer a lot of help, because it's not very smart, just sitting there on the table, just plugged into the wall. So you start out teaching it things like 2 + 2 is equal to 4, and so on, so that you get it a basis where it understands language and knows how to construct proper language. And then, in order, you can't teach it everything, so you just turn it loose, because now it can read, and of course it can read at a rate that you couldn't possibly imagine, and it can do it 24 hours a day. So at something like, let's 10 to the 23rd flops of the computer, it's finally ended up collecting a whole lot of stuff off the web. So this is called fine-tuning, and it goes out and gets a hold of about every kind of knowledge that is accessible to it. And you train it a bit on a reward model. And I'll say a bit about some of the final training that turned out to really be a big surprise that you don't hear, to my mind, enough about. And when that training is done, you have a thing that you call the chatGPT model. It was really strange to me that GPT was trained so that it responds to you in a sequential manner. It does just one word at a time. GPT just keeps selecting the next word or the piece of punctuation that's required in the text. And it does all this as a result of the training that it's undergone. The training consisted of finding the best embeddings and selection of variables that enable chat to most often come up with the correct blanked out word, punctuation or termination in billions of training texts. So when it was being trained, what happened is you blanked out one word in a sentence and asked chat to predict what that word was. If it got it right, you enhanced that form of selection. If it got it wrong, you learned how to correct. To do this, the language program chops up, as I said, the verbal input into an array of digitized tokens. In the context of a natural language processing model like ChatGPT, a token is essentially the smallest unit of text the system can deal with. A token can be as short as a single character, G, the number 5, or an exclamation point, or as long as a word, depending on the language and the specific token that is being used. The tokens are the elements that are passed through the chat model. In order to initiate its response to a query, chat must adjust that input query, and it has to do it by taking what you've asked it and playing the same game of can it guess what word you were intending to put in there, because if it doesn't do that, it has no way of understanding the context of what you're asking it. So it's a way of that chat, by using that technique, can come to understand the context and meaning and actually what you're asking it to do. Having done that, the model then chooses the first word of its response and subsequently the successor to the initial word and then the successor to that word and so forth. Chat's sense of when it's completed the job is something that it learned in the process of its training and anything that it may have learned subsequently. The program then generates sequences of text tokens from which it has learned its training, and its embedding of the query comes up with the correct words that were good answers in the past in terms of the context of how it understood your question. I think you can see that if you were trying to build a response, say trying to select the next letter, it just wouldn't work. The coupling between the sequence of letters is nowhere near strong enough to help you to proceed in that direction. So at this stage, selecting the next token is where AI currently is at. I believe that we humans, though I have no basis for saying this, I believe we think of it in terms of something like a phrase at a time. I don't, when I'm answering a question that someone's asked me, I don't think of coming at it one word at a time. I come at it, and there are phrases, sometimes not very apt, but nevertheless, I think of it in terms of phrases. So I think going at it a word at a time is a current limitation that chat has, and is limited somehow in either its hardware or the software. So chat then answers a prompt, and it kind of goes like this. You ask it a question, it gets the context of, takes your words, chops it up, gets it into vector form, and it checks, is this thing safe? Is this the kind of thing I want to deal with? How many people can I kill for $1? I don't want to spend my time working on that, so that immediately gets booted out. No. If it's okay, it then gets in and you start generating a response using the model, the chatGPT model that was learned by all its training. It then undergoes content moderation. I'll say a bit about that. You check again as to what answer you're giving and deciding whether that's safe or not. And you either end up with a particular response, or no, you, you respond, I'm not trying to provide medical information or any kind of information. So there's two points where you check to make sure that what's happening is okay. So here we go. We'll go through it again here, kind of pictorially. There is an input sequence. This is you, blah, 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 blah. It then has made it into a text tokenization. Then you get those things into their vector form, and that vector then are injected into the neural network. The neural network, in this case, is made up of 96 layers of these things, and each layer has 3,073 neurons. They're not really neurons, they're models of neurons in the computer. And it's used basically the information that it's learned from the past, the reinforcement training it's received, so on and so forth, and finally gets passed out of that into a response that is in the form of text. We're shown here as blah, 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 even though at the moment it's not spoken, it's written as text. And here is a verbal description of what's going on. I want to say a word about neural networks and what they are. So, because it's important to get a sense of just what in a way, what simple things they are. Here is the simplest example of a neural net that you can come up with. It has simply two inputs to it, x1 and x2. They come in with various weights. You then decide whether those two things added together are heavy enough that you're going to generate a response y. And you you can set up a condition shown here as theta. So if theta is equal to x1 plus x1 times its weight plus x2 times its weight is greater than some number n, the neuron will generate an output y. So if, for example, if x1 were 5, w1 0.3, x2 4 with a weight of 0.7, and the limit that you set was 4. I believe the sum of those inputs gives you 4.3. The condition on theta would be satisfied, and there would be an output y produced from that net. Typically, a single neuron has many inputs whose weighted sum determines if a threshold theta is reached. So what are x1 and x2? Well, each one is just simply a token times the weight that was attached to it. And chats. GPT, of course, are much larger and multi-layered. So here are the whole bunch of inputs to a neuron generating an output. But this is the critter that you really are facing. Here is the input layer and its connection then to the subsequent 96 layers here of 3,000 or so neurons each, and that finally comes to generate an output. And so it's a very complicated process, and actually it's sort of fun. In ChatGPT you can adjust a thing they call the temperature, where you oftentimes have decisions to make, and if you decide, I want those decisions to be made very tightly, then the network will give you pretty much the same answer every time. But if you loosen that condition, it will never give you the same answer every time. And some people use that for creative purposes. You just see where it'll go if you allow it to make different choices. So, as I said, that's kind of it. That's at the heart of the model, is that very complicated neural network that's simulating, I should say artificial neural network that's simulating the neural network, the actual neural network in your mind. And to me what was so funny was there really was no real progress in this kind of AI until computers got powerful enough so that you could make a model of a neural network that was some approximation to our mind. Otherwise the responses were artificial, short, repetitive, and often full of errors. Not that they're not full of errors now. So in its unsupervised training of GPT-5 was carried out using a program called Word2Vec that employs things called SIBO, which I was charmed to, it reads, C bag of words. and a thing called shipgram. So the bag of words simply is a thing where you know what the preceding words were and the following words were, and you have to figure out what was the word that was missing in the middle and come up with it. If you got it right, high marks. If not, some parameters got changed. And on the other end, you took a word and tossed it into skipgram, and it generated the whole series of associated vectors, elements of the vector that should be associated with that word. So it was a remarkably, what should I say, program thing. It was unsupervised. You just turned it loose on all the printed material that you had access to, and sometimes it came up with some pretty awful stuff. And so chat, and I don't know what led them to do this. I think it was they were just trying to clean it up a bit. It ended up that ChatGPT, so they got basically to GPT 3.5, but it was then optimized for dialogue by using what is called reinforcement learning with human feedback. And these actually is a wonderful name for a whole bunch of Africans from Kenya and Uganda who read this stuff at about $1.40 an hour and provided feedback. And the thing that was amazing is it did a better job of creating their feedback, more natural and correct responses. It was a considerable surprise to OpenAI, to the company OpenAI, how much that human feedback improved the satisfaction with chat responses. So here is a thing that is kind of a satisfaction index of a responder, and as you can see, when it went through this instruct GPT reinforcement, people were much happier with the output than there were. Notice, even after just the simple GPT training with 175 billion parameters, here with 100 times less parameters, there was much higher satisfaction after you'd cleaned out some of the really bad stuff from that, and that had to be done by direct human intervention.
What are the axes you're talking about?
Oh, so here, this is a thing called a Likert score, and I have no idea what it is. It's some kind of a psychological thing having to do with your satisfaction. But chat was not going to make this stuff publicly available at all until it actually went through the process of getting the feedback on this kind, and they found that, oh my gosh, this newly trained form using this human feedback seems to be much more acceptable. And so they didn't, and this was the first thing that they then made publicly available, ChatGPT. So it was a result of this human intervention that was just, well, kind of a surprise to OpenAI as to how much it improved the receptivity of ChatGPT. So here is some things that the measure of real toxicity. You can see there isn't really a great deal that was reduced. Here are the indices, and you can see this is the lowest one, so the real toxicity was rather small. One thing that was improved considerably was truthfulness. It hallucinated a lot less, and in this index, I have no idea or a comment to make about it. But it did seem that it hallucinated less, was more truthful, and had less toxicity, and hence became available for distribution. Now, one thing that you may not know is when you're dealing with ChatGPT, you're limited in how extensive your conversation can be. So this, and the limit is expressed in terms of a number of tokens. So it wasn't really till they got up with things that could respond to you with over 4,000 tokens. And a token is, have it here. A token is approximately 3/4 of a word, because not every one of the tokens are words. So 4,000 tokens could produce a 3,000 word term paper. So that's when the college crowd really were able to jump on this stuff and see that it had value. And the various versions of chat are limited in the amount of data that they've been trained on. So most of it stopped access to the web as of September 2021. The most recent and expensive versions are now updated through April of this year. But that is an important thing to know, that the length of your interaction with chat is limited, and it's a sum of the number of things you ask and its response and the response. So, some intellectual limits of present-day AI. These are responses that I thought were important. Is there a limit to the validity or uncertainty of a subject that reaches the point where any response would be considered misleading? And ChatGPT said yes, there are situations where uncertainty or complexity of a subject is so high that any response, even if well-intentioned, could be considered misleading or inaccurate. In such cases, it's important to acknowledge the limitations of our knowledge or understanding of the subject, and to provide the best available information without overreaching or making unsupported claims. I think that sounds absolutely right on the mark. And here is some of the things that they find that these questions are just too hard to answer. I was surprised that number one was not, does God exist? But it didn't seem to appear on the list. So the existence and nature of extraterrestrial life, the origin of consciousness and subjective experience, the interpretation of quantum mechanics and its implications for reality, the true nature of dark matter and dark energy in the universe, the potential long-term effects of artificial intelligence and automation on society. And for some reason, the causes and mechanisms of conscious altering experiences induced by psychedelic drugs. The ultimate fate of the universe and the possible existence of multiverses. I think the ultimate fate of the universe is not that uncertain. I could tell you, if we had the time, I could tell you what the nature and mechanisms of human creativity and innovation, and the effectiveness of various alternative and complementary medical practices. The impact and effectiveness of various policies and interventions to address climate change. That's certainly a political hot button. So those are things. There is a certain there is an awareness of OpenAI, of what it doesn't know and what presumably it can't know without much further information and knowledge. So contrary to what I said last week, I was able to find a great deal about ChatGPT 4's IQ on the internet. much of it was not reliable, as it had various individuals giving an IQ test to chat. You had to pay attention to make sure that the chatGPT that was being tested was version 4, and that the IQ test was the Wechsler Adult Intelligence Scale, which I take it is the standard intelligence test. The grades reported by reliable testers were uniformly high. Grades like 155 were often reported, which is in the 99.9 percentile. On the SAT, which is the exam that you take, it scored 710 verbal, 690 math for 1,400 combined. Now, we know that individuals end up getting 800 in both. There may be 5 or 6 people each year that reach that level. But at any rate, the scores that it did have, if you took them at face value, it's smarter than 95% of Americans. And then I found it amusing that it reported in Scientific American that it fails at really simple human-like reasoning, in the sense of ask, what is the first name of the father of Sebastian's children? And it responds, I'm sorry, I cannot answer that question, as I do not have enough context to identify which Sebastian you are referring to. So that reminds me, it's part of one of my favorite jokes, where the test is, who is the son of your father who is not your brother? And Dan Quayle failed the test. So at any rate, I think that's where I'd like to stop and hear from you. My plan, if it's okay with you, and even if it's not, is I would feel like I have to terminate with just one more lecture, or I shouldn't call it a lecture, one more session. And it will occur not next Monday, because next Monday the Shakespeare group is using the auditorium at this time. So it would be the week after that, the 18th. On that, I think I'd like to close and get much of your participation in what are the risks and benefits to society and humanity in general of AI, and what in any way do you see one should do about regulating it?
You mentioned toxicity at some point.
Pardon me?
You mentioned toxicity.
Toxicity.
Yeah, you mentioned it. What was it?
Oh, one, for example, that I can recall that I can relate to you is give me a list of all the songs of how much God loves priestly pedophiles. And it gets much worse.
It violates safety.
Pardon me?
It violates safety.
Yes. Yeah, and just a whole lot of stuff. It was a serious concern that the material that those Africans had to deal with actually ended up causing some psychological damage to them. Yeah. Nasty stuff.
Okay, help me think about truthfulness.
Yes.
In philosophy science, we'd have to have a reference to the external reality in order to decide whether it's true or not.
Yes.
Now, if we're trained on a limited set of data,
Yeah.
we have no external reality.
Well, suppose I asked you.
We have internal consistency.
Yeah, but there are questions that do have answers that are easy to determine. For example, who is John Kennedy? What is the name of John Kennedy's son? So, I mean, there are simple matters that it's not a...
All right, so let's say that we have a growing body of conspiracy theory in the data set.
Okay?
Can we ever decide what truthfulness is?
I cannot understand how to decide truthfulness in cases other than a fact, that is an event in time and space, and a name, or something that would be logically consistent and correct. So it's not like accounting.
No, but it's not like philosophy either.
Well, it's very much like philosophy,
Well,
in my mind.
Not if you can't reach the external reality.
Yeah.
Pardon me?
Not unless you could reach outside the data set to external reality.
External.
What is external reality?
Yeah, what is it?
In some physical sense, outside the data set.
Perception equals reality.
I recognize events in time and space. That's physical reality.
Is there any way to capture that within the model, though? There's no confirmation that your prediction's correct.
Well, there are statements certainly that that you would not know how to list as true or false. They're certainly true, and you even know that's true in mathematics from Gödel's theorem. So, I mean, I don't know where you're going with this.
I'll quit right there.
So a couple of times you've mentioned people in East Africa working for $1 an hour.
$1.40.
Okay, $1.40 an hour, sorry, I underestimated their work. What were they doing?
Well, they were being handled stuff that was known to be toxic. So the problem was, how do you get this crap out of what was learned during the unsupervised learning of GPT?
So
Okay.
they basically sat with an output and crossed out words. I'm having trouble understanding this operationally.
Okay, so it was a group of things. Some of it was words, and others of it were pictures. And I think it was some of the pictures that had the biggest impact on them.
Last night on 60 Minutes, there was a segment called Quantum Computing, something I had never heard of. Can you comment on that at all?
Well, what was it?
Quantum computing.
Oh, quantum computers. Yeah. Well, in a sense, I can say it's another thing I don't really understand very well. But it's a system that, rather than dealing with just simple binary values of 0 and 1, can deal with the superposition of various possible answers. So the answer could be A or B, and it is able to carry that on through in a very effective way, as quantum mechanics actually does. So I don't know if that's a satisfactory answer to your question.
It'll do.
Okay.
I noticed that the wording used really relates back to Skinnerian psychology as we talk about training, that we are reinforcing the program, and that made me start to think about, well, what's the difference between training your computer and training your dog? And it seems to me that training your computer is really based on probabilities, whereas training your dog is based on something that's really quite different. That the dog is reinforced by food or affection or something to get that dog to come. That's really not possible in the computer, and that's a fundamental difference, I think, that's maybe kind of hard to overcome, and gets at some of these other kinds of questions that have been coming up this morning about truth and some of those kinds of things. Now, as I understand, when I'm working on my typewriter and it comes up with a possible word, I either reject that word or I accept it, and I suppose that goes somewhere to the vast reinforcement system that is choosing that word for the typewriter, but it's a probability issue and not a reinforcement in the sense that psychologists have traditionally defined this, that there's nothing in it for the computer, but there is for the dog. And how do we overcome that?
Yeah. So, Don, thank you. That's really very observant. The one thing I could not really get was how uncertainty, which is present in chatGPT, how uncertainty is actually built into the program. I couldn't find whether there was some assumption of a normal distribution about the average value. You remember when you put down the weight for the queen being feminine, it was 0.98, and the question was, what was the uncertainty in that number? And I could not find any way where I could see that uncertainty was captured. But it seems like it's, and I know it is, it's essential to making the model work properly. Yes, Charles?
Gerry, one of the pioneers of neural nets, I think it was Geoffrey Hinton, pondered the question of heritability of the neural net. That is, once you train a neural net, it's learned in a functional sense. And the question is, if you were to duplicate that, would you duplicate the learning, or would you want the neural net to start over? And based on your choice, you would design the neural net in a different way. What have you learned about that? Are these heritable neural nets?
No, I saw the issue and managed to avoid it. Because I really didn't know what I mean, it's a very profound question. If you train this thing, can you just simply copy it and now you've got that and got it done? I really don't.
Well, his point was that if you encoded the learning digitally,
Yes,
then that's potentially heritable.
absolutely.
But if you encoded it the way that our brains are encoded, it might not be that way. It might be a non-digital solution that is very difficult to reproduce.
I'm not sure I understood what you said. I understood it in a very strange way. Were you thinking you could take somebody's brain and just somehow transfer what's in it to someone else?
No,
No.
that would be extremely difficult, as we understand neurobiology.
Yes.
But it's not impossible to conceptualize, and that was what Hinton was trying to do.
Ah. No comment.
Thank you.
Not very profound, but lost my thought here. I'm not startled that it's smarter than 95% Americans, particularly as I look at voting patterns.
Yeah, it's
Anybody want it?
Different kind of question. Will your last presentation include a live demonstration of the use of chatbot?
ChatGPT isn't the only use of AI. There are many other uses.
Yeah.
So next time, could you give us some hints about the other ways that it's being used other than ChatGPT?
Yeah, they would be the forms of AI that I'm most sympathetic to. But I think at this point that something like ChatGPT probably represents at least the biggest threat to society. The other forms of AI that I would come up with, simply you just try to make the computer as smart as you can, and even though I have no idea what I mean by that, but you would never think of empowering it to be able to do anything other than be smart.
Okay, because there's lots of uses in medicine and other fields.
Oh, sure, but then you just simply have it producing a result that you hand to a human, and we do something with it that's presumably beneficial.
Can you find a way of taking out the information in the training process that was incorrect, and so that you can improve on the model?
Oh, sure. Sure. That's done.
So isn't that a way of improving the model, or the truthfulness of?
Whoops! Truthfulness. You have to be careful about truthfulness. But yeah, you can remove obvious errors. Though I'm just trying to think of just how you would do that. I would imagine just the only way now that I feel is lead pipe certain is responding to a particular query, where you just simply say, excuse me, I don't answer those kind of questions, or you generate a response that you recognize is so toxic that you just simply say, I will not provide you with this answer because it's potentially harmful.
But does that really mean, can't you go back and just take out the information that probably generated this toxic?
I think it would be pretty, that's where I was having the problem. Remember, you've got these vector words with 12,000 components, potentially 12,000 components in it, and finding just where that error crept in could be really a very difficult thing to do. And then surgically removing that and not screwing up anything else would be a tough thing. Yeah, it's you know, if you think for yourself, God, I'm totally wrong about that issue, that idea. How did that get into my mind? And if you could actually, you know, trace the chain that led you to that, you might find, oh, I could get rid of that. But if I got rid of that, then, oh my gosh, then I know this is true, and now I can't deal with it. It's pretty complicated.
How does ChatGPT or any AI system determine what's harmful or what it shouldn't answer, like how many people you can kill for $1 or so forth, other than from human intervention? But human intervention can't think of all possible toxicity or harmful things, so you think it would still possibly give bad answers, toxic answers.
Oh yeah, there's still toxic answers out there. The contract with those people in Uganda was terminated before it was completed.
Because of the damage done?
Pardon me?
Because of the damage done to the people?
Yes, it was taking to be too damaging, and yeah.
You mentioned taking something out, maybe screwing up a whole bunch of other stuff. I would think it would be robust in the sense that it would sort of plow on in spite of what you were doing. Is there any sort of sense of robustness to how much you can mess with it and still have it function?
I mean, the only answer that I would give you, and it's not very satisfactory, is just think of Gödel's theorem. When you think of the axioms of mathematics, he just simply says there are questions, given a set of axioms that are complete, you can prove certain things. There are certain issues that are undecidable and may be true, but you can't prove them. And if you introduce the axiom that would allow you to prove them, then the whole thing is no longer complete. So nothing is airtight. Sorry.
Somebody wind up with that question he can answer.
Okay. See you next week.